All right, this is about how to evaluate the trig functions of an angle in a right triangle. So for this angle theta, I want to find all 6 trig functions of the angle theta. So I have to remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and then the other 3 trig functions, cosecant, secant, and cotangent, are the reciprocals. So I always write them out like this. So sine of theta is going to be the opposite over the hypotenuse, which is 7 over the square root of 65. And then I think we should rationalize it. So I'm going to multiply by root 65 over root 65 and get 7 times the square root of 65 over 65. Cosine of theta is the adjacent over the hypotenuse, which is 4 over root 65. Multiply by root 65 over root 65 gives us 4 root 65 over 65. And tangent of theta is equal to opposite over adjacent, which is 7 over 4. The reciprocals I always write next to each other. So sine, the reciprocal of sine is cosecant. So cosecant of theta. Honestly, I never think of cosecant of theta as being the hypotenuse over the opposite. I just think about it as being sine flipped over. So you could say it's the hypotenuse over the opposite, or you could just say it's the reciprocal of 7 over root 65, which is root 65 over 7. It's also nice to see it in this original forms, because when you flip this over, you end up with the root on top, so you don't have to rationalize it. If you flip this over, you'd have to rationalize it again, which is a pain. Similarly, secant of theta, you can either say secant of theta is hypotenuse over adjacent, or you could say it's the reciprocal of cosine, which is going to be root 65 over 4. Sounds like I'm talking about like root 66, but it's not, it's root 65. And then cotangent of theta would be the reciprocal of tangent, so I could just say it's 4 over 7, or I could say cotangent is adjacent over opposite. So cotangent of theta is 4 over 7. It is very standard to write the trig functions of a particular angle out in this order. Sine, cosine, tangent, and then next to each one, they're reciprocal. Cosecant, secant, and cotangent. Okay, let's do it again for this other triangle. This triangle is a little bit different. First of all, it's oriented differently. Second of all, we don't know the third side. So before we can even find sine, cosine, tangent, etc., we have to find this third side here. So I'm going to use the Pythagorean theorem. I'm going to call this side, I don't know, x. So since x isn't the hypotenuse, right, it's not going to be 2 squared plus 3 squared equals x squared. It's going to be 2 squared plus x squared equals 3 squared. And the hypotenuse one is always the one that goes by itself, and the other 2 legs squared get added together. So then solving for x squared equals 9 minus this 2 squared, which is minus 4. So now minus 4 is 5, and x is going to be the square root of 5. We don't worry about the plus or minus here, because when it's a triangle, we kind of just say all the sides have positive lengths. It doesn't usually make sense to think about a triangle having a negative length. So this here is the square root of 5. And now we can find sine, cosine, tangent, etc. Now, it always depends on which angle we're looking at. Right? If this is the angle, sine of alpha is the opposite 2 over the hypotenuse 3. But if we were looking at this angle here, like if this angle was theta, sine of theta would be the opposite root 5 over 3. So it really depends on which of the 2 acute angles in your triangle you were looking at. So here, sine of alpha is equal to opposite over hypotenuse, 2 over 3. Cosine of alpha is equal to the adjacent over the hypotenuse, which is root 5 over 3. Right, the hypotenuse is never the adjacent. The hypotenuse is always just the hypotenuse. The adjacent is the side next to it that's not the hypotenuse. Finally, tangent of alpha is equal to, tangent is opposite over adjacent, which is 2 over root 5, which we would rationalize by multiplying by root 5 over root 5 as 2 root 5 over 5, right? Because the square root of 5 times the square root of 5 is just 5, or the square root of a thing times the square root of a thing is always just the thing. Cosecant of alpha, I'm not even looking at my triangle, I just know it's 3 over 2. I could look and say, oh yeah, cosecant is hypotenuse over opposite. Secant of alpha is going to be the reciprocal of this, which is 3 over root 5, which rationalizes as 3 root 5 over 5. Finally, the reciprocal of tangent of alpha is going to be cotangent of alpha, which is going to be root 5 over 2. Or you could look at the triangle and say cotangent of alpha is adjacent over opposite, which is root 5 over 2. So that's how you find the trig functions of angles in right triangles. And sometimes you have to find an unknown side using the Pythagorean theorem.